Welcome to Coach Taylor's Honors Geometry Notes. Last time we looked at algebraic proofs. Now we're going to look at our geometric proofs. So our geometric proofs just means we're going to use our geometry problems and geometry vocab that we've learned so far this year and do proofs over those types of questions. So here's just a real quick list of everything that we learned last unit that we could use to prove information in a problem. So you've got your law of detachment. So if the hypothesis of a conditional is true, then the conclusion is true. So if P then Q is true and P is true, then we know that Q is true. Our syllogism. If P is Q is true and then Q is R, then R is true, then we know that P then R is true. Our segment addition postulate, AB plus BC equals AC. Our angle addition postulate, the measure of AOB plus the measure of BOC equals the measure of the entire angle. Remember, our segment bisector cuts a line in half at its midpoint. An angle bisector cuts the angle in half and creates two congruent angles. Congruent segments, we know that congruent segments have the same length. Same thing with congruent angles. Congruent angles have the same measure. We know that all perpendicular lines make right angles. Midpoint, we know that a midpoint divides a segment into two congruent segments. So our linear pair postulate, if two angles form a linear pair, which means they are adjacent and they are on a straight line, we know they are supplementary. This one's kind of 2-in-1. We know that all right angles are congruent to each other. Because right angles are 90 degrees, all right angles are congruent. We know that a right angle is an angle whose measure is 90 degrees. Complementary angles is two angles. When added together, we get 90 degrees. Supplementary, the sum of two angles is 180 degrees. Vertical angles, we know they are congruent. We know if two angles are congruent and supplementary, so if they are both congruent and supplementary, then we know they are right angles. Our congruent supplements theory, if two angles are complements of the same or they're congruent, then the two angles are also congruent. Same thing for, I switched these up. So that's supposed to say supplements, and that one's supposed to say complements. Two angles are supplements to the same angle, then those two angles are congruent. And so these are going to be the rules that we use to prove these geometric problems. So let's look at this first one right here, and let's remember that when we have a given, this is the start of our problem. So our given is that G is the midpoint of segment F. So that's what I'm going to write down in my first one. G is midpoint of FH, and I'm going to put the segment marker on top so I don't have to write segment. And the reason I know this is because it is given. So this is where we have to go to our definition of midpoint. So what we know about a midpoint is we know that a midpoint divides our line in half. So we know that line segment FG is equal or congruent to line segment GH. And the reason we know this is because our definition of midpoint. And again, that definition of midpoint is on the previous page. And so if it's on that previous page, then we can use it as a reason, which is our Y. So the other thing that the problem tells me is it tells me what the length of FG is, and it tells me what the length of GH is. So using that information, I'm going to substitute both of those sections in for FG and GH. So because I know that 11x minus 7 is the same thing as FG, and I know that it equals 3x plus 9, which is the same thing as GH, I can just substitute those two algebraic expressions into the problem. So now I need to solve the problem using my algebra. So I dislike negatives, so I'm going to add 7 to both sides, which is my addition property. This leaves me with 11x equals 3x plus 16. My next step that I'm going to do is I'm going to move 3x to the other side because the 11x is lonely. So I get 8x equals 16, which is my subtraction property. And then finally, I'm going to use division to get the x all by itself. So I know that x equals 2. And if I look back up here at the top of the proof, this I know is my end. And once I get to x equals 2, I know I'm done. So I need to write down division property. So now let's look at our next example. All right, so my next problem. I'm given that, so we always again start with our given. This is the information that we know to be true. So we know that angle WXZ and angle ZXY are complementary. So now I need to go back and look at my geometric proof. So because I know they're complementary, what do I know about complementary angles? Okay, so now I'm going to use my definition of complementary angles. And what this tells me is that two angles have to be the sum of 90 degrees. So that's what I'm going to write. I'm going to turn these two angles, WXZ, actually the measure of WXZ plus the measure of angle ZXY equals 90 degrees because that is my definition of complementary. So what I'm looking for and what I'm trying to prove is I'm trying to prove that the whole angle is a right angle. So I know that part plus part equals the whole angle. And so my postulate or my theorem for that is going to be my angle addition postulate. So angle addition postulate. So I know that the measure of angle WXZ plus the measure of angle ZXY equals the measure of angle WXY because of my angle addition postulates. Two angles that are inside one add up to equal the one angle. And so now I need to use my property of, or my transitive property. Because remember, our transitive property says that if we have the same thing, which is angle WXZ plus the measure of angle ZXY, twice, whatever those two things equal become equal to each other. So using transitive property, I know that the measure of angle WXY equals 90 degrees. And then I need to prove that it's a right angle. Well, I believe that we have a definition of right angle. So let's see what that definition of right angle says. Definition of a right angle is an angle whose measure is 90 degrees. So I'm going to use the definition of right angles, because once I know that WXY is 90 degrees, I know that angle WXY is a right angle. And again, once we get to that, we know that we're at the end and that we can stop with our proof. And so that's how we can use our geometric concepts that we learned in the first unit to solve geometric proofs.